So it's a pleasure to be here. I'm so glad to be here at the Algebraic and Geometric Methods of Analysis, the International Conference. I would like to thank the professors Maximenko and Prishliak for their invitation. They were very kind to me, and also Professor Yegorov. So the recent proposals of three-directional time or time vector of six-dimensional space-time with SO3 and 3 symmetry have renewed the interest for the hexadimensional extension of Einstein's general relativity, formulated 2 decades ago and later refined. We wish to enrich the discussion about the hypothesis of the three-dimensional time by giving an intuitive geometric response to 2 fundamental questions. Why should the space-time manifold require 6 dimensions instead of 4? Why should the 2 extra dimensions be time-like? We believe that the current representation of the space-time's intimate structure is incomplete. We suggest adding the spin angular velocity among its intrinsic properties. If we assume that each point of the continuum is a structureless rotating sphere of null radius, we obtain a 6D inherently spinning space-time. The acronym is ISST. A single point of the ISST is identified by 6 coordinates, 3 spatial, determining its position, 1 temporal, 2 time-like, defining its spinning axis. The 2 parameters necessary to describe the orientation of a spinning point are interpreted as time extra dimensions for being surface measures, surely not space-like, that is, not related, not linked to the position in a fixed OXYZ reference frame. Our topological analysis raises open questions ranging from the observation of a preferential arrow time to the role of temporal hidden variables in classic quantum phenomena. 2002, Gunther Mucho proposed a three-directional time. 2020 again, Christian Rakotonirina proposed a time vector. Still in 2020, David Chester and other people proposed a 6D spacetime with SO3 and 3 symmetry. But in 2007, we gave a talk in the 93rd Congress of the Italian Physical Society entitled Extension of Einstein's Relativity, which was based on the three-dimensional time. We proposed to replace the Einstein field equation in 4D, four-dimensional, the ordinary Einstein field equations, with the Einstein field equations in 6D, six-dimensional equations over SO3 and 3 symmetry. Although multidimensional time theories are edged out of the mainstream, such work raised an unexpected interest. Construction of the 6D ISST. A point in the continuum is a structureless rotating sphere with null radius. It is an axiom. The inherently spinning space-time ISST, each point has its own spinning axis. The plane of rotation of each point is identified by 2 extra parameters. 2 extra parameters are time-like, so that the ISST is 6-dimensional. Where and when does an event occur? We all know it. General relativity's Einstein field equation are rather difficult, but the logic behind the 4D manifold is trivial. The minimum number of information needed to identify an event is 4, connected to where, 3 spatial coordinates, and when, 1 temporal coordinate, it occurs. Although rational, such construction is incomplete, according to our opinion. How does an event occur? we should respond to a further question. How can an event occur? The answer is an unexplored property of the continuum. Each point could spin. It means that any point is viewed as a structureless rotating sphere of null radius, with an intrinsic spin angular velocity axial vector omega. Only the plane of rotation is essential. We ignore both the magnitude and the direction up or down of the pseudo-vector omega, focusing only on the plane of rotation perpendicular to the spinning axis as essential information about how an event happens. We adopt the Saturn icon to highlight the orientation of each spinning point. Two time-like extra dimensions. The plane of rotation of each spinning point has an orientation defined by two parameters like, for example, the first two classic Euler angles, alpha and beta. We interpret alpha and beta as time extra dimensions because they are independent from the event's position, that is not space-like, and as surface measures, they are basically time-like. Where do time extra dimension hide? An ISST event has 6 coordinates. If the point orientation does not change, time extra dimensions alpha and beta should not show up. It means alpha 1 equal to alpha 2 and beta 1 equal to beta 2 in the passage between the two events E1 and E2. The invariance delta alpha is equal to delta beta and they both are 0 could be the reason why two temporal dimensions are hidden, letting us perceive time passing only as t. Feature of the 6D ISST. An event is described by 3 space-like and 3 time-like dimensions. The 6-dimensional ISST implies 6-dimensional Einstein field equations. Each event is represented in reference frames with 3 spatial lines and 3 temporal surfaces. A cosmology based on the ISST would not require neither dark matter nor dark energy. Let's see very quickly the features about the ISST. There could be time, and I got some documents to suggest in order to deepen such questions. But very quickly, our ultra-hyperbolic space-time extends 6-dimensionally everything about general relativity, starting from metric tensor, quadratic form, arriving to the Einstein field equations. The geometry of the flat 6D ISST could be referred to this improved Cartesian-like reference frame with 3 spatial lines and 3 temporal surfaces. If we consider a curved space-time, it becomes a Gaussian reference frame, where the lines are not necessarily neither rectilinear nor mutually orthogonal, and the 3 temporal surfaces are not necessarily neither plane nor reciprocally orthogonal. Cosmology is very interesting about the 6D space-time because we saw in another conference that it could explain both the dark energy and dark matter without recurring to the lambda CDM standard model. Conclusions. The 4 dimensions of Einstein space-time manifold define where and when an event occurs. We have asked a further question: how can an event occur? The answer consists of spinning angular velocity associated to each point of the continuum as Euclidean axial vector. Linked to the axiom of punctual spinning axis, 2 time-like extra dimensions extend the 4D framework of the 1916 general relativity towards a new 6D geometric dynamics. The inherently spinning space-time is compatible with any 6-dimensional scenario on SO3 group. The ISST's topology entails a revision in depicting 2 quantum phenomena and our mindset in time perception. What I mean is that there are three open questions. The double slit experiment in 6D, if we consider two extra time coordinates, two extra time dimensions, we could save the general relativity setting, albeit in 6 dimensions. The quantum tunneling also could find explanation. So if the particle, for example, an electron or an inner particle or inside an atom, would like to overcome an electronic barrier, it simply don't find the barrier, the energetic barrier, at the time when it passes it, because there are two extra time dimensions. And the last open question, a four-dimensional mindset. What would happen if the reason of the hidden time variables was our mindset, instead of a punctual orientation of the surrounding continuum? If our minds were set on a particular pair, alpha 0 and beta 0, we could recognize only events with a specific orientation. Those are the references and the image credits. Thank you for your kind attention.
Alexander, звук.
Thank you very much. Do you have any questions?
I have a question. Please, dear Enzo, what do you think about the idea that your space-time is a direct product or skew product?
May you repeat? My space-time is what?
Direct product of
direct product.
Direct product, yeah.
Of what? Of which variables?
First space is our space time with 4 dimensions, and the second product is your product.
Yeah, I understand now. Okay, so today's talk is just about topology. So your question has been already explored by three, if I remember exactly their names, David Chester and Alessio Marrani. They think something about the possibility that the 4D universe we experience is a direct product in a certain way from the SO 3 and 3 universe. But today's talk is something a bit different. Many people, a lot of people, are thinking about the 6-dimensional universe. But the reasons are because it works, because it is elegant, because it fits with some quantum features. I asked myself, but is there a geometric basic reason why our universe should be 6-dimensional? And the answer I found was because when we think about the point, we have to add another feature. The point is not static, but could be considered rotating. If we introduce this property as intrinsic, we could explain in a purely geometric way why the 6-dimensional universe could exist. It is a purely topological consideration. But your question should be replied by David Chester in an article Beyond the Standard Model with 6-dimensional space-time. It is on archive. It is a preprint.
But how we can observe change of the last variables, last time like variables.
So when you consider a spinning point, you need 2 extra parameters because you need to orientate the point. So not only where, so x, y, z, and when, t, you find it, but how you find it. It has an orientation. These 2 extra parameters are not space-like because they do not depend on the position. And in an article of mine of 2015, I will suggest it to you if you are interested after, I found some reasons to associate surface measure to time-like measure. So there are strong hints that the 2 extra parameters are time-like and not space-like.
Thank you.
Thank you.
Any more questions?
Yes, can I ask a question? You said about parameters that they can't be observed in our universe. So the question is connected with observables. It is known from astronomical observations that there are dark matter and dark energy. It is known facts, measurable.
Yes, yes.
But you said that your geometry does not connect it with this observable. How can you explain this disagreement?
This is a secondary aspect. This talk, today's talk, is not about the consequences of a 6D universe, but about the reasons why we should accept it. But if the 6D universe should be found one day correct, among its gifts, among its properties, there will be a lot of good things. For example, Xiaodong Chen found in 2005 the possibility to explain a lot of quantum phenomena with 2 hidden temporal variables. And going furthermore, there are many attempts to find cosmological explanation avoiding the hypothesis of dark matter and dark energy. And they are all connected to the change of Einstein's field equation. It would be just a possibility. It is not the focus of the talk of today. It is not a cosmological talk, but just a way to say the 6-dimensional universe that is considered good for its connection with a possible bridge toward between relativity and quantum mechanics, a possible bridge between cosmological standard model and alternative models. Does it have a geometric foundation? And now I'm suggesting it. The inherently spinning space-time. This is the focus of my talk today. But if you are interested in this specific question, how the cosmology of the 6-dimensional space-time could avoid dark matter and dark energy, I can suggest you something of 2 or 3 years ago. I can send you some material about it. It is just an hypothesis, of course.
I don't know any theoretical interpretation which is consistent with modern observables, but there are theory of the brain or superstring theories, known theories which are try trying to explain this.
Yeah, of course.
Very
Yeah,
soon.
just attempts, especially in cosmology. We are like blind people, so we are trying to find something to explain. But as Sabine Ossenfelder noticed, we are trying to find some ways, but we don't know which is the real one. Maybe that the six-dimensional space-time could work also with dark matter and dark energy. It is not a specific feature in one 6D space-time. There is also the possibility to explain some anomalies in a geometric way without recurring to dark energy and dark matter.
Sorry, just a bit naive question. Suppose we observe an electron,
Yeah,
in space-time.
yeah,
And we turn off our observation, changing the last time-like variables.
yeah. Yeah, perfect. So imagine that you have, for example, the quantum tunneling. So you have a barrier and you have a particle. The particle, the electron, as we observe it, cannot overcome the barrier. But because we see the barrier now and we see the electron now, if we had two extra dimensions, what the electron sees could be not the barrier now, but a space-time, an event where the barrier was not there. So the electron passes because for it, there is no barrier, as if we go in a place where they didn't build the wall of the castle in a period when they didn't build it. And after, when we are on the other side, if the orientation changes, the barrier reappears. It was like a sort of overcoming the barriers, but not in a spatial way, in a temporal way. We are going inside a protected castle before the walls were built. And when we are inside, we can set our time in the right time, and the wall appears. That is the quantum tunneling explained without renouncing to the concept of trajectories of a particle.
Okay, thank you very much.
You've been very, very kind and also very
Yes.
curious. I'm glad.